Hi everyone. Here we are going to see about the Unit 5. Unit 5. So that is the Introduction to Digital Signal Processing. So in this unit, we are going to learn about the what is DSP and what are the processors used in the DSP. Then we are going to see about some of the architectures and also addressing modes for the architectures. Then types of arithmetical methods. Next we are going to see about the uh, processors architectures, then addressing modes types, as well as features of the architectures, then memory organizations. After that we are going to see about the adaptive noise cancellations, everything. So let me see one by one. So the digital signal processing system. So here when we are passing the analog signal input, we will get the analog signal as an output. So how we have to get these analog signal input output means, first the signal, analog signal, that is the sine wave signal, is passed into the anti-aliasing filter. Anti-aliasing filter means that is it will having the filter that is used before the signal sampler to restrict the bandwidth of signal to satisfy the Nyquist-Shannon sampling theorem over the band of interest. So is this anti-aliasing will be very important for used in a digital imaging to reduce the visual defects, and it will occurs when high resolution images are presented in a lower resolution. Next thing will be the sample and hold circuits. So that is this output of the anti-aliasing filters will be passed into the sample and hold circuits. So it means that the sample and hold circuits is the also known as a sample and follow circuit, which is an analog device, and it will be uses the samples, that is the captures, that will take the voltages of continuously varying the analog signal and holds its values to a constant level for a specified minimum period of time. After that, this output will be passed into the analog to digital conversion. This analog to digital conversion will be convert the discrete values and passed into the digital signal processing system. After that, this digital signal processing system will be used for to convert these and convert the values, convert the analog to digital conversion method by using the digital processing by computers or more specified digital signal process to perform a wide variety of signal processing operations. So it is applicable to both streaming data and static data set. So next it will be passed into the digital to analog conversion. After that it should be reconstruct the filters and then passed into the analog signal output. Next is the perspective of the digital signal processing problems. So here we have used that application areas. So for example, so first that is the application areas where we have used this digital signals means. So first we are passing the component technology. That component technology will pass into the processor instruction sets and hardware functions. So that will be used for implementation as well as the architectural process. After that, these values will be converted to the algorithms and then passed into the basic functions. So that in basic functions there will be the theoretical problem modeling is affected. So it will be makes the modeling level as a function, sir, and then passed into the digital signal processing theory. The digital signal processing theory will having the so many applications, sir. So that is the medical, radar, speech, seismic images. All these things will be converted to the digital signal processing and then basic function. Then it will be given to the processors. After that, we will get it to the component technologies. Next, Dsp Application Characteristics. So the application requirement processor will attribute real-time processing, that is the high speed and high throughput. So large arrays of the data will be having the instructions to move and process the large data. Arrays means there is the algorithm which will be having the intensive mathematical processes, and it is a fast computation, single cycle Dsp, single cycle and Dsp method. So the operations will be having the mapped that is system flexibility. So it should be having the general purpose method and programmability. There is a EEPROM microcontroller or microprocessor mode will be programmable in the system flexibility for the Dsp application characteristic levels. Next, different approaches to the hardware implementation. So here we are using the hardware implementations. That is the high speed general purpose computers and custom designed VLSI components. So first thing will be that high speed general purpose computers. So here it is a very programmable and we can be configured for the control. So the programmable will be expensive and configured level will be complex when compared to the other methods, other purposes of computers that we have used in the implementation. So different applications have been used, that is the input as well as the output overheads are used. Next is the custom designed VLSI components. So that is, it is efficient design specific and that is applications should be used in most of the components. Large throughputs development of cost is very high and it is compared to the other components that have been used in the implementation process. Next is the general purpose digital signal processors. So that is we have to combine the programmability and the control features of general purpose computers and the architectural innovations of special purpose chips. So its goal is to high speed, low power and low cost. So this should be maintained in the digital signal processing method to contain the programmable level to improve that implementation. Next, general purpose computers. So that is flexible. The general purpose of the computers are, it is very flexible for using the computers in most of the performances. It is suitable for the internet and multimedia applications. So most of the computers are very suitable for all the purposes. Next, it is a software intensive. That software intensive means there is they can install the so many softwares based on their computer devices. So it is slow for the high speed applications and fast for the low speed applications. So it is too bulky and the power will be very hungry. That is we can use this power for particular usages. So if we use daily means that the power will be becomes hungry for changing the battery level as well due to the usage of the purposes usage of the programmable computers. Small register files force lots of memory access. So that is it should create these small register files that forces the lots of memory accesses. So these are different from a cache since these are the programs that should be managed. Next thing will be the complex instructions issues, logic, branch prediction, speculations, etc. That are not needed for DSP. So it is not enough ALU functions and it should be not adequate dynamic range and precision, sir. So these are the conventional processes that should not be suitable for the digital signal processing systems. Next is the data processing versus signal processing. So that is the general purpose microprocessors which should be designed primarily for the data processing. So the primary burden is data read or write processor. So it will make the signal processing method more easy to use in computer systems. So the digital signal processors which will be having the microprocessor that is designed by the signal processing systems. So the primary burden is mathematical operations, and the DSP architecture therefore incorporates the certain features not found in the general purpose microprocessor system. Next thing will be the Dsp requirements. So that is the emphasis is on mathematical operations. So it should be rather data manipulation operations like processing, database management, etc. So design is optimized for Dsp algorithms which will implement the FIR filter, FFT generator, etc. So the processing is real time, that is the input signals will be comes continuously, and the output signal is also produced continuously as the input is acquired. So the dominant mathematical operation is multiply and accumulate. So on separate inputs it is in parallel method. So that all these DSP requirements should be very important for the database management systems. Next thing will be the digital signal processor features. So that is the features are it should cater the high arithmetic demands. The real-time operation should be used. Next, analog input or output method is processed. Large number of functional units for a given size, and small control logic.